welcome everyone to the show. I'm so excited to have Dr. Geary here with us. I'm going to just do a quick introduction and we're going to jump into the meat of our discussion today. Dr. David Geary is a cognitive developmental psychologist with interests in mathematical learning and in evolution, which I thought was really interesting. He has published nearly 250 articles and chapters across a wide range of topics, including cognitive and developmental psychology, education, evolutionary biology, and medicine, including sole authored books such as Children's Mathematical Development, which some of the interventionists that are watching this are probably familiar with that book. It's been around for a long time. Currently, he's working with the University of Missouri on a long-term study of mathematical development, the MU Math Study. Dr. Geary, welcome. Is there anything I forgot that I should definitely mention?
Well, thank you for inviting me, and thank you for your interest in this work. Yep, the MU Math Study has done a number of projects now. We did a kindergarten to ninth grade, a 10-year longitudinal study, preschool to first grade, a 4-year study. We're just finishing up a 6th to 9th grade algebra focused study. And we hope to do a follow-up on the young kids, the preschool study starting next year.
Oh, that's so exciting. I'm thrilled to hear that because I think there's so much more work to do there. It's definitely, yeah, I feel like we're just scratching that surface.
Yeah.
That's great. Well, one of the things that I did before joining you is I asked parents and interventionists and others in this work, what questions would they want to ask Dr. Geary if they were here? And so I've got those here. So one of the questions that came up is one thing that frustrates them is that there's so many names for referring to a math learning disability. So we have the dyscalculia, a math learning disability, or a learning disability with impairment in mathematics. And so what they're wondering is, are we talking about the same thing, or are there really differences between them?
Yeah, great question. And it is very, very confusing, even to me sometimes. The dyscalculia term comes from neuropsychology and neuropsychological studies. So individuals who have a stroke or other types of medical issues, then having difficulty with often arithmetic or number processing, those types of things. And some kids studies, kids have early medical problems or presumed problems that are assessed in a medical school, medical setting by neuropsychologists would often get the term dyscalculia. So there's a long history of work in that area. The disability stuff, learning disability stuff, not surprisingly comes from educational studies. And so that's the focus there. The question of whether they're different populations is a good one. For a dyscalculia diagnosis, you'd have to have long 3-hour plus neuropsychological evaluation, maybe MRIs and other types of things. And so the numbers of kids identified through that means is much smaller than the numbers of kids identified with achievement tests, for example. But probably there's a huge amount of overlap between them.
Yeah, I would think so too. And I think some of the neuropsychologists that are making those evaluations are using terminology that a school would identify with to help the child get accommodations and changes to an IEP.
Right. Yeah, I think in our work, the big issue is whether kids are lower achieving multiple years in a row. Mm-hmm. So we have kids that they do poorly one year and the next year they're fine, and their working memory, cognition, and so forth is just fine. They just had a bad day when they assessed. But if you get multiple years, then you're getting into the difficulties, disabilities.
Yeah, absolutely. And that segues actually beautifully into the next question that an interventionist sent in. So she was more curious about that retention piece for retaining the math that's being taught. These are students that have had multiple years of failure. And it does seem to be that many of our students will learn the material in a hands-on, concrete way, systematic, direct instruction like you've suggested in your research. but there are times that they struggle to really retrieve that knowledge.
Yeah.
What can be done about that for those kids?
Yeah, that's a great question. Yeah, memory retrieval issues are a big problem with a lot of these kids. I've collaborated with some folks looking at the brain systems associated with the learning and memory of basic facts and other types of information. And yeah, their retrieval deficits are real. I mean, they are retrieving things, but often they're retrieving kind of the wrong thing.
Mm-hmm.
They're getting the wrong number there, and there may be some issues in how the hippocampus and other areas involved in memory formation are kind of wired up a bit. There have been some intervention studies, though, looking at that system, and have shown that with sufficient practice, sufficient organized practice, it can be straightened out in elementary school kids, at least.
Yeah, absolutely.
Yeah, so more generally, though, having practice distributed over time, rather than have mass practice and not do it ever again. You kind of spread it out over time, giving reminders, practicing, interleaving things so that you're practicing, subtraction and division together.
Mm-hmm.
Maybe one page after the other, addition and multiplication together, so forth. So you're mixing things up, which requires kids to pay more attention to what they're doing, rather than just kind of whatever comes at the top of the head. They have to figure out what type of problem it is.
Sure, absolutely. I agree. Earlier, you mentioned if you're getting an evaluation, sometimes that might involve an MRI, those kinds of things. So is there some significance to that? Can we see the differences in the brain through an fMRI or other scan between like a neurotypical average achieving brain versus a student with a math learning disability?
Yeah, there are some brain imaging studies of kids who are low achieving on a standard math achievement test, and you do a functional MRI where you give them math problems to solve while they're being scanned, and then you can look at the networks involved in that system. And there are differences, and there are a number of differences there, some of which are correctable for some kids with enough intervention experiences. Probably, though, the best indicator is just straight achievement tests. They're actually more reliable than the MRIs and fMRIs.
Okay, that's good to know. And then I'm curious, what made you decide to focus on this math side of the learning disabilities? There's so many other places you could have chose to focus on. What draws you to studying math learning disabilities specifically?
Yeah. Good question. When I was in, I liked math growing up, and as a kid, I did reasonably well in it. When I went to graduate school, I was studying cognition, cognitive development, and my advisor was kind of a statistician type and was interested in certain types of modeling of how people solved, at that time, arithmetic problems. So I got involved in that work. And then prior to going to get a research PhD, I had done a master's degree in clinical child and school psychology. And so I was interested and familiar with all of the achievement and psychological tests and some of the issues in the learning disability area. So it seemed to be an area that was ripe to explore. Kind of just by chance, those two things came together, and I thought, well, we'll run a few studies and see if anything interesting comes up from it. And some interesting things did, and we've continued with it.
Yes, absolutely. Last night I was reading some of your research about those preschool counting skills with the puppet and counting the objects one by one. And I thought it was really fascinating that if you double counted the first object, the student didn't catch that error, which is really interesting. Did you ever explore what happens if you double count in the middle of the sequence?
Yeah, I don't think we did that. Yeah, missing the double count at the beginning of it's a kind of a working memory error. They probably notice it, but they forget by the time the
Hmm.
time
Hmm.
is over. So that's common with a lot of these kids.
Yeah.
Um, we've gone back earlier, to the preschool years and looked at conceptual understanding of number and number development in like 3 and 4-year-olds. And that actually is even better predictor of school entry readiness for math learning.
Absolutely. And do you have any screeners you recommend for catching those kids at those ages if we can identify them earlier?
Yeah, that's what one of the things we're hoping to start a project on, hopefully starting in the fall, looking at
That'd
at-risk
be great.
kids and following them for several years and looking at different measures and trying to figure out why some kids are kind of having difficulty with these basic number concepts, like understanding the word 4 represents 4 of any object. There are there's experimental measures that can be used to assess those, but there's no kind of standardized measure of it just
Yeah.
yet.
Oh, I would love to see something like that. That would be fantastic.
Mhm.
I want to hear more about this most recent research that you've been doing that you just wrapped up. I know the MU study page said that you're working on writing the papers, the algebra pieces and readiness. I would love to hear more about what's driving that work and if you're allowed to share maybe some of the interesting things that you're seeing.
Yeah, sure. So we assessed almost 2,000 kids in the local school district here in basic arithmetic skills and attitudes, anxiety about math at the end of 6th grade. And then we recruited 342 of them to continue for 3 more years through the end of 9th grade algebra. And so we just finished the data collection for the 9th grade algebra stuff last spring, and so, but we have done some preliminary findings. One thing that might be interesting to your listeners is we looked at performance on the 6th grade measures, and then we got end of course algebra scores from the school district that the state requires students to pass this algebra test before they can graduate. And so we wanted to look at predictors of later risk of failing algebra.
Mhm.
And we found that was involved 2 things: understanding of fractions,
Yep.
not surprisingly,
Not
but
surprising.
yeah, yes, specifically fraction magnitudes,
Mhm.
and then understanding non how to solve non-standard arithmetic problems presented in a non-standard format.
Mhm.
So x plus blank equals 3 plus 5,
Mhm.
or x plus or 5 plus blank equals 3 plus 5. So the blank, the number you have to fill in, is on the left
Right.
rather than the right. So if they can
That's
do
really
that,
interesting.
if if they do that, it suggests they understand mathematical equality.
Mhm.
But a lot of kids don't get it, and
Yeah.
they make errors on those problems. And that was the biggest predictor for the overall kind of almost 2,000 sample.
Wow.
And then we did it with controlling for things like working memory and other types of things to make sure it was a knowledge specific deficit.
Mhm. That's
And
really, really interesting. Yeah.
yeah,
And so, um, one way we could maybe approach that, or I guess I would love to know your thoughts, is introducing these algebraic ideas of equivalence and what that equal sign means a lot earlier, like in the early elementary years. What do you think about something along those lines?
yeah, I think a lot of those types of things are already being done, or they're starting to be done, where kids are being exposed to problems in a variety of formats rather than the standard A plus B equals give me the
Mhm.
answer sort of format, which many kids then make the inference that the equal sign just means solve the problem.
Yeah,
rather than the
yeah.
left, right, being
Yes, equal
mathematically.
sizes. Yes, I love that. I think Dr. Shin, she focuses on word problem study, and she was finding the same kind of thing, that we need to be putting in and interjecting that algebraic thinking much earlier, especially with word problems, which is really interesting. So I really enjoy her work, and it aligns with what you're finding. That's really exciting.
Mhm.
So what other current trends are piquing your interest in students with math learning disabilities right now? What would you like to study next?
Well, in our previous preschool study, we're wrapping up the algebra studies now, and then in a previous preschool study, we tried to identify the early competencies, early number counting, and so forth competencies that predicted readiness for math learning at the beginning of first grade. In particular, performance on a measure we showed in a prior study is that's a long-term predictor of math outcomes. And we identified those differences, as I said, mostly related to conceptual understanding of the meaning of number words, and presumably Arabic numerals as well, and kind of the quantities represented by those. And we found huge variation even among 3-year-olds. So starting 2 years before kindergarten,
Mhm.
some kids already had a pretty good grasp of it, and some kids didn't know even what one meant in terms of quantities. So there was huge variance there. And that early variance predicted readiness for math learning 4 years later, controlling parental background, cognitive ability, executive functions, all sorts of other things, even controlling prior standardized math achievement. And so what we want to do now is look at the home background, kind of how parents interact with their kids around number, magnitude, and stuff. We want to look at how engaged they are in preschool settings, what their teachers are doing, and expand our studies of kind of what the kids know to try to get a better handle on what's driving all this variation among 3 and 4-year-olds that is
Yeah,
predicting later risks for long-term problems.
that
So
is great.
yeah, that's a 4-year project. So it'll be a while before we have the results of that, but that's the next focus for us.
I'm happy to hear you're not slowing down. I want you to keep going.
Yeah,
Um,
yeah, I may slow down after this one, but we'll see.
you might slow down after this. What I think is interesting about that study is then we could also kind of look at what's happening with, because we know we can find students with dyslexia at a
Mhm.
young preschool age. And so I think it'll be interesting to kind of look and compare, because I know you've also compared that with math learning disabilities and a reading disability and the overlap that happens there. I think
Right.
you said that 50% of kids with a math learning disability also have a reading disability. Am I remembering that correctly?
Yeah, yeah. It depends how you define them, but that's probably about right. There's a lot of overlap
Yeah.
between those. Yeah, yeah. One of the goals is to identify early predictors of long-term problems, but also to understand what is influencing the development of those predictor skills, so that the next study would be an intervention to try
Yeah.
to reduce those differences.
That's really, really exciting. And I'm thrilled to hear about it. I know in my own home, I have 3 boys, one with dyslexia, the other 2 were a breeze to teach to read, right? But the one with dyslexia was severely different. So it'll be really interesting too to hear like how the home environment is affecting that numeracy that you're looking at. I'm really excited to see what you find.
Yeah, 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 yeah. Thank you. Yeah, there have been some studies, a fair number of studies that have looked at it, but the results are mixed. I mean, it's not really clear yet, and we're going to be looking at everything: the kids' development, the home, the parents' math skills, what happens in the classrooms, and try to integrate it all together.
I love that. And are you going to be looking for, maybe is there a genetic component if a parent says that they struggled with math? Are you going to be watching those kids a little closer?
Yeah, we haven't. Yeah, we probably don't have enough big enough sample to do that. But
Yeah.
what we'll do is we'll look at the parents' math skills, so how they do on math achievement tests, and how that influences the complexity of their math number related interactions with their kids.
Yes, I
So
think that's great.
Yeah.
Well, the other question everyone was wondering about, we love that you're out there, you're doing the research, you're publishing often. We're so thrilled about that. What can we do as parents and interventionists and those who are interested in this work too, from the kids' side, trying to help remediate and get these kids the help they need? But we want to know, what can we do to support researchers and making sure you're getting funded and getting the props that comes to you, because a lot of your work affects what we're doing as well. How can we support your work?
Okay, great. Yeah, thanks. Yeah, I think just supporting, having support for more basic research on learning problems. Congress comes up with reallocation of funds for learning disability status and research, supporting places like the National Institutes of Health and National Science Foundation that support a lot of our work and others' work in this area that funds it. And I think also encouraging teachers and school personnel to stay aware of this work, because a lot of it's been basic, but there are a lot of interventions that are now being developed from preschool all the way through fractions and other word problems and so forth. And so staying, making sure they stay on top of the latest research. So they're doing kind of best practices.
Yeah, absolutely. Yeah, and because I know that's a real issue, to get the research into the classrooms where we can actually start making a difference for kids right away. Those are great tips. I love it. Well, those are the questions that we wanted to ask. Really, we had tons and tons, but we want to respect your time. So we can wrap it up there, but I'm gonna go out on a limb here. Dr. Geary, do you have any math puns that you happen to know, or jokes?
Yeah. I don't know of any math jokes. Yeah, good question. Yeah, no, got me stumped.
I got you stumped.
there. Yeah. But if you come up with any, send them to me, and I'll
Actually, if you'll bear with me 2 seconds,
Sure.
I'll pull one up. I forgot to leave it pulled up in my window so that I can quickly show you. We actually keep visual ones for our team so that we can share, dorky math jokes together. So let's do, we love a good joke here. Okay, I'm going to share my screen, and here it is. All right. They're dumb. They're dumb. I didn't say they were good, but they're dumb. Complementary angles. Inspire me. You're doing a great job. Oh, excellent. Thank you so much for being here with us, Dr. Geary. It was such a pleasure. Again, we'll always have your back. We'd love to help you. And we look forward to seeing the papers that come out about the algebra.
All right, great. We try to keep an updated list on the MU Math Study webpage. So there'd be a list of articles there, and you can get a lot of them through Google Scholar. Or
I saw that, which I really appreciate. Yes, that's great. Thank you so much.
You're welcome. Have a good day.
You too. Bye-bye.